like 3 hours. All right. So we're going to be factoring still polynomials. The difference as we move forward here is instead of having it already set equal to 0, you got to set it equal to 0 to find the zeros of that. So that's one of the things that's different. Another thing that's different is maybe a technique that we want to use here. So for this one, if we were going to factor that, what method would we try? Why would we do grouping? Because there's 4 terms. That's absolutely right. If I group this, what's the GCF of that first group? X squared, and that leaves x plus 4. What's the GCF of that next group? -3. But that leaves x plus 6. Is that supposed to happen? No. So what that means is that won't factor using grouping. Okay, this is where our other technique comes in. Okay, because grouping doesn't work. That was the method we could try, but that doesn't necessarily mean it works. So what we've got to have here is I'm going to give you that x minus 2 is a factor. I'm going to give you that information today. I'm going to either give you a factor or I'm going to give you a 0 of the polynomial to start off with so that we can start employing another technique for factoring. Okay? If x minus 2 is a factor of this, that means that if we divided this polynomial by x minus 2, the remainder would be 0. Okay? It's kind of like 4 is a factor of 12 because 12 divided by 4 goes into it evenly, right? Because 3 times with the remainder 0. So 4 is a factor of 12. 8 is a factor of 24 because 24 divided by 8 goes 3 times with the remainder of 0. That's what it means to be a factor. So if x minus 2 is a factor of this bigger polynomial, that means if I divide this larger polynomial by x minus 2, the remainder will be 0. Okay? What method of division would I use with this factor? Or could I use? And we had 2 options. Synthetic or long. We can use synthetic only when what we're dividing by is what? Doesn't have exponents. Does x minus 2 have exponents? No. So we can use synthetic. Okay, so what we want to do is use that synthetic division here. 1, 4, -3, -18. What goes on the shelf? +2 or -2? Why? That's right. Y'all remember that? Set x minus 2 equals 0, you get 2. All right? So we're setting up a synthetic division to take this polynomial from cubic 3rd degree down 1. That's what we want to do. So I'm telling you that x minus 2 is a factor. So let's remember how to do synthetic division. So what do we do first? Bring the 1 down. Now what? Multiply. 1 times 2 is 2. What do I do with 4 and 2? Add. Multiply. Add. Multiply. Over here's the remainder. It's 0. If it tells you that that's a factor and you don't get 0 there, you did something wrong. Something went wrong. You either misadded, mismultiplied, or forgot to put a 0 in the missing place or something like that. Okay, so make sure of that. Now, so that takes us from a cubic down to a what? Squared. All right. So we have x squared plus 6x plus 9. This is how we're factored so far. Will this quadratic factor? How? X method, multiply to be 9, add to be 6, 3 and 3. So the factors are x plus 3 and x plus 3. And then the one they told us about was x minus 2. That's our factored form. Okay? So that's what we were looking for on that quiz, the factored form. That's what I'm looking for, something like that. Now, to get the zeros, what do I do with each factor? Set them all equal to 0. So x minus 2 equals 0, x plus 3 equals 0, and the other one is x plus 3 as well, so I'm setting it equal to 0. So I get x equals 2, x equals negative 3, x equals negative 3. How many answers is that? What was the highest exponent on the original problem? 3. That matches it. That's not a coincidence. That always happens, okay? Here's our function. Let's go fourth power. X to the fourth minus 3x cubed minus 27x plus 81. And x minus 3 is a factor. Let's see if we can do this one. So our job is to factor this and then get the zeros of it. So today you're going to get a factor given to you or a 0. We're doing factors right now. Can we use synthetic division? Yes, because this doesn't have exponents. What goes on the shelf? Positive 3 this time. Okay, x minus 3 set equal to 0. Solve that, you get 3. All right. Top row, 1, negative 3, 0, negative 27, and 81. Why in the world did I put a 0 in the middle? Not an x squared, so I've got to have a representative. Remember that, because if you don't put it there, it can cause problems. Doesn't always cause problems, but it can. It very often does if you don't put it there. Okay? Run that through with synthetic. Should be getting a little faster at that. All right, wonderful. So far, we factored it as x minus 3, and then what's this polynomial here? We started at x to the fourth, so x to the third, 0x squared, 0x, minus 27. Hey, what's that? Difference of cubes. So we can factor that. There's the x minus 3 they told us about. That's a difference of cubes. So that's x cubed minus 3 cubed. So we know a difference of cubes has a short piece and a long piece. What's the short piece for this one? Another x minus 3. I did them in different colors so that you know they're different ones. And then what's the long piece? Plus 3x plus always a plus on the third part of the difference or sum of cubes, always a plus. Okay. Will this quadratic factor any further? You could try the x method, multiply to be 9 and add to be 3. So you can do that? No. If it comes from a sum of cubes or a difference of cubes, you can pretty much always know that won't factor in. Okay, so now, what do we do to find our zeros? Set all of these equal to 0. Even that quadratic one. Those first two are easy. They both give us x equals what? 3. So we got 2 of our answers. We should be finding how many answers? 4, because the highest exponent on the original problem was 4. Okay? If that won't factor, how do I find my answers? Quadratic formula. Equals negative b plus or minus radical b squared minus 4ac divided by 2a. Work that out. So negative 3 plus or minus be 9 minus 36, negative 27 over 2. And simplifying this, what kind of solutions is this going to give us? Too complex because our discriminant is negative. Okay, so we know there's an I involved because it's a negative underneath there. So we break down the 27, 9 and 3, 3 and 3. There's a pair of 3s. So that simplifies a little bit. Negative 3 plus or minus 3i radical 3 over 2. I would take it either of these ways. This is how you'll normally see it, like in textbooks and things, but I would take it that way. So either I'll box them both of those. So the 27, we had a pair of 3s. That's just 3 on the outside. The other 3 in my factor tree up there, that 3 on the inside is that one that we didn't have a buddy. So that's that 3 on the inside. The I came from the negative, and then nothing. I can't simplify 3, 3, and 2, so I'll leave it alone. Okay. So here is negative 3 plus 3i radical 3 over 2. That's one answer. Negative 3 minus 3i radical 3 over 2 is the fourth answer. So we got 1, 2, 3, 4 answers on that. Okay. So this is taking what we just worked on, and okay, well, what if it doesn't work with our normal methods? What do we have to do? So, and I'm giving you a little bit of information to help you get started with this. So let's do one more of those, or 2 more of those actually. Here's our function. X to the 4th power plus 7x to the 3rd power plus 11x squared plus 7x plus 10. How many terms does that thing have? A lot. 5. Do we have a method for 5 terms? Grouping we do have a method for. That's 4 terms. That's a semicolon. Okay. Let me make that more clear. Semicolon. That looks like a J. There's a little closer to a semicolon. Their factor. I'm just going to write x plus 5 out there. That's our factor. Trying to simulate what you're going to see on practice. So we have the polynomial, and then we have the factor listed right after that. So x plus 5 is the factor of this polynomial. Okay. As we progress, we're going to learn how to find that on our own without somebody telling us. So, not today. I don't think we got time to get there today. What goes on the shelf? How do I know that I can do synthetic? No exponents on the x plus 5. Hey, come on. Yeah, but you have to do math when you stay here. They can too. Sorry, I shouldn't have cut you guys like that. Sorry. Sometimes the truth hurts. 1, 7, 11, 17. Coefficients. Run the negative 5 through with synthetic division. If you don't get 0 as the remainder, you did something wrong. You miscopied a problem. You misadded, mismultiplied somewhere. Okay. So far, its factoring is x plus 5. And then what's this polynomial? x cubed plus 2x squared plus x plus 2. What's my method for factoring that? Grouping. I group the first two together. They have x squared in common. X plus 2. Second two together. They don't have anything else in common but a 1. So the factors, there's the x plus 5 they told me about to begin with. And this is one of the things I just going through the front of the quizzes. I hadn't got through everybody's yet. But a lot of folks were getting here and then just forgetting to write the complete factored form. This is not factored form. That is halfway done. Another adverb to describe that, but this is factored form for that. That right there is factored form. This, not factored form. Okay? Don't stop short.
In factored form can be then the base exponent. Is it interchangeable with the
Do you mean like rearrange the pieces, these parentheses that we're talking about?
Yeah.
Yeah, you can write it in any order. If you wrote x plus 5 and then x plus 2 and then x squared plus 1, perfectly legal. You can put that in any order you want to, but it doesn't really matter what order you put it in. There's not a rule about that. This is the factored form. Once you get it to factored form, what do you do with factors? Set them equal to 0. So x plus 5 equals 0. I'm going to do x plus 2 equals 0 because those are similar. And then the x squared plus 1 is equal to 0. And that's one that some folks had some trouble with on quiz that I saw. Not a ton of folks, but some. This is getting x is -5. This is getting x is -2. So there's two of our solutions. To solve this one, we subtract 1 and get x squared is equal to -1. Then you take the square root. What's the square root of -1? I. One, two, three, 4 solutions. Highest exponent, 4. Goes together. Yes, sir. Difference of squares. Should have been factored with difference of squares. So you should have at least got 2 answers. Yeah, the plus or minus on both, like that one, it factors is x squared plus 4 and x squared minus 4, and then x squared minus 4 factors is x plus 2, x minus 2, and then so you get x equals plus or minus 2, and then x equals plus or minus 2i, because you solve it.
I've got a question here. I got one. The lowest quiz grade is now maybe can be taken away too.
Yeah, I continue that policy. Yes.
How do you do the one? How do you factor the polynomials with the exponents that are like multiples of each other? Like there's something in the
X method. X method, you factor it like a quadratic, and when you replace your middle terms, you use the middle piece. Let's do another one of today's stuff. These are all questions that you probably should have asked yesterday. We had 85 minutes to work. All right. 12x to the 4th plus 5x cubed minus 50x squared minus 20x plus 8 is our polynomial. And the factor that we know about is 3x plus 2. Okay, so that means when we divide by 3x plus 2, we should get 0 as a remainder. Can I do synthetic? Yes. Is this one fun? Yes. One-third squared. Okay. What goes on the shelf? Negative 2/3. Okay. Again, that comes from setting 3x plus 2 equals 0. Subtract 2. 3x equals negative 2 by 3. All right. Drop the 12 down. Change colors here. Multiply. What's 2/3 of 12? Negative 8. Add those together is negative 3. What's negative 2/3 of negative 3? 2. That's negative 48. What's negative 2/3 of negative 48? Try again. 32 there, 12 there. I hope that's where you meant the 12, right? Negative 2/3 of 12 should be negative 8, right? Because our remainder is supposed to be 0. It is negative 8. No magic involved there. So the factoring so far is 3x plus 2. And then this is 12x to the third minus 3x squared minus 48x plus 12. What method do I employ to group? First two, 12 and 3 have 3 in common and 2 x's. Got that where you can see the 12. And that would be 4x minus 1. 48 and 12 have what in common? 12. And because that's a negative 48, it's going to be a negative 12. That'd be 12 times 4 is 48. So that's 4x minus 1. That's not factored form. From this point home. A lot of you could get there, but then you were stopping short of getting your factored form out of that. So we actually forgot to do something there at the beginning of that, but we'll fix it in a second. Yeah, there was a GCF, but I'm gonna show you how to fix it if you forget that. Some of you had that same problem. So we got 3x plus 2, and then 3x squared minus 12, and then 4x minus 1. That's not completely factored yet because will any of these factor a little further? Yeah, they got a GCF right here on that. What is the GCF of just this piece? 3. So I'm going to pull a 3 out of that. And that'll give me 3 and then x squared minus 4. Okay? So this part, I'm just factoring the 3 out of that, and that's giving me that. Will x squared minus 4 factor? Oh, yeah. Beautiful stuff. The 3 that I pulled out, I'm going to put it to the front. So that's 3 parentheses 3x plus 2. What does x squared minus 4 factor as? It's the difference of squares, isn't it? X plus 2, x minus 2. All right. This one's nice because it got us 4 really nice factors that we don't have to do quadratic formula or anything for. Okay? This 3 that's in the front, it doesn't have an x on it. So does it matter as far as finding the zeros? No. It is in the factored form. It's important because the only way that this is the factored form of the original is if that's there. Okay? So this is the factored form. The zeros, you just set anything that's got an x in it equal to 0. So 3x plus 2 equals 0. We already know the answer to that one. And then x plus 2 equals 0. X minus 2 equals 0. 4x minus 1 equals 0. Set those equal to 0. So that's going to be negative 2/3. That's negative 2. That's 2. 4x minus 1, what's that end up being? Positive 1. Because you move the 1 by addition. So we get 4 zeros for a polynomial that started out with an exponent of 4 is the biggest one. Okay. Given factors, that's what we're going to do. If you're given a 0, it doesn't change the game very much. Actually, not at all. Okay. What's the difference in a factor and a 0? What's the relationship between a factor and a 0? What's that relationship? Thank you, sir. If I tell you negative 2 is a 0, what was the factor that went with that? X plus 2. So this, same thing. The only difference is when I put a number on the shelf, what goes there? The negative 2 that's already given to us. I don't have to solve that factor, set it equal to 0 and solve it. Okay? They're just giving me the number to put on the shelf. That's the only difference in this and what we just did. Okay? So this is my shelf. Okay? So set it up. Negative 2 is on the shelf. 1, negative 1, negative 10, negative 8. Run that through. What should the remainder be? 0. What do you know? Yeehaw. So if I'm factoring f of x, what's the factor that went with it? Negative 2? X plus 2. What's this? Can I factor that? X method, right? Negative 4 had to be negative 3. So it'd be negative 4 and 1. So x minus 4, x plus 1. I still got the x plus 2. That's the one they told me about. They called it a 0, but we know that's what it came from. So we got the x plus 2 equals 0. We got x minus 4 equals 0. We got x plus 1 equals 0. We already knew that negative 2 was a 0. We're verifying that. We know that 4 is a 0. We know that negative 1 is a 0. Exactly what we just did. Instead of starting with a factor, we're starting with a 0. So we don't have to change the sign. That's the only difference. Do another one. F of x, x to the 4th power minus 7x cubed plus 5x squared plus 35x minus 50. Get some bigger numbers in there. 5. 0. And my dyslexia kicked in. I spelled 0 wrong. 5 is a 0. What's that mean we do? 5 on the shelf, right? Set up for synthetic, put a 5 on the shelf. 1, negative 7, 5, 35, negative 50. Run it through with synthetic. Break this polynomial down. 1, 5, negative 2, negative 10, negative 5, 25, negative 10, that's 50. There's a 0. Hey, it means I did my arithmetic right. If I don't get a 0 right there, I did something wrong. I had to have misadded, mismultiplied, or miscopied something even. Okay. So, what's the factor that goes with the 5? X minus 5. Goody. What's this? What method would I use to factor that? Grouping. X squared, and leave us x minus 2. What do I pull out of that second group? Negative 5. Factored form, I got x minus 5, I got x minus 2, and what's the third factor? X squared minus 5, right? Will any of those factor further? Will that one not factor? Why not? It's not a square number, right? If that were a 4 or a 9 or a 16 or a 25 or 144, 256, some square number, it would factor. Because it's 5, it won't factor any further. So what do we do to find our zeros? Set them all equal to 0. And this is where some other folks had some problems on the quiz that I saw. This one, that one we already knew about. This one's easy. Folks didn't miss those. It was the, thank you so much. Then the next one, this is where folks had problems. You got to get x by itself before you start taking square roots. You got to get the x squared by itself. A lot of folks were wanting to just jump in and do square roots right there. That's not where that happens. Move the 5 over by addition. You get x squared is equal to 5, and then take the square root. Is there an I involved in this one? No. When is the only time there's an I involved? If it's negative underneath the square root, okay? So 5 doesn't break down any, so we just leave it plus or minus the square root of 5. 1, 2, the positive square root of 5 is 3. The negative square root of 5 is the fourth answer. The highest exponent on our problem to begin with, 4. Not a coincidence. Math works that way. Beautiful. That's why I like it. Things work together for a reason, all right? So